Hello guys, I welcome you all to my channel CSNet Lectures. So in this session we are going to discuss about graph types. So around there are 20 types of graphs that are present in data structures. So in this session we are going to discuss only a few of the graph, and in the remaining sessions, that is in the remaining two sessions, we are going to continue its type discussion. Okay, so this is also a very important topic of data structures. So you may get questions both in theory wise or in some problematic wise. Okay, so all the important points and all the important informations I am going to discuss it with you in a smart way. So friends, it is your duty to note down all the points which I tell it now. Okay friends, so we shall go for the discussion, right? So friends, I have displayed here what are all the different types of graphs that are present. Okay, so the first graph is directed and undirected graph, and the second one is weighted and unweighted graph, and dense graph, sparse graph, cyclic graph, directed acyclic graph, cycle graph, infinite graph, planar graph, Euler graph, regular graph, connected, null, trivial, complete, finite, bipartite, simple, pseudo and Hamiltonian graphs. Friends, these are all different types of graphs. So all these graphs seems to be very easy for you. It is an easy implementation. So among these 20 types, I am going to tell you which are all very important. Okay, so in a semester examination also they may ask this question. Okay, so some of the graphs are very important, so I will just mark, you can just make a note of it. Okay, so this graph is a very important one, bipartite graph, and then planar graph is very important, and next is Euler graph. So this is also a very important one, and then Hamiltonian graph is also very important. Okay, so in this we are also going to discuss another one important point. So that is handshaking. We are going to discuss even about this. So we are going to concentrate on important points of these graphs. So now we are going to start the discussion of each and every graph types. Okay friends, shall we proceed? So friends, the first type of graph what we are going to discuss is directed graph and undirected graph. Okay, so what is a directed graph? So if you see in the diagram, you will be able to find the difference. See, we have marked an arrow mark, and here we have not specified any type of arrow marks. So that is a main difference. So the meaning is it has a pair of ordered vertices. So a directed graph is going to have a pair of ordered vertices. So what is called order? So order is nothing but order of moving from one vertex to another vertex. So that is called as a ordered vertices. Okay. So meaning is, for example, 1 to 2. If I am going to write 1 to 2, the meaning is the traveling, that is the passage will be from first vertex to second vertex. So this is called as your ordered pair. So and another one thing is, it is having a unidirectional, that is the direction is only in one way. So the one way is being mentioned. See, we are going to travel like this, and for here we are going to travel from here to here. We cannot able to take the reverse direction because the actual path is being given. So it is a unidirectional graph, right? So we can pass in any one of the direction based on the order that is being given. So next is an undirected graph. So what is an undirected graph? See, we have not used any arrow mark. So the meaning is we can move in either of the direction, that is it is not in order. So we can either move from 1 to 2 or we can move from 2 to 1. Okay, so this is an unordered path. So an undirected graph is able to travel in both the direction. So it is a bidirectional graph. Can you understand? So it consists of a pair of unordered vertices, right? So next one we are going to see another graph which is called as a weighted graph. So what is a weighted graph? So the weighted graph is nothing but we are going to give a weight for each and every edges. Okay, for example, you take this graph. Can you tell me what are all the vertices and what are all the edges? So here the vertices are 1, 2, 4 and 5. So these are all vertices. So edges, if you see, how many edges are there? So 1, 2, 3, 4 and 5. So there are 5 number of edges for this graph. So if you just notice down, I have not mentioned any values for the edge. Okay, I have not mentioned any values for the edge. Suppose if I didn't mention any value for the edge, okay, so then it is called as an unweighted graph. So what is the meaning of a weight? I just want to tell you with an example. For example, if I want to travel from Salem to Chennai or from Bangalore to Chennai, okay, what is the actual kilometer to travel? So all these things will be making a note of it. For example, from Bangalore to Chennai, if I just want to travel, I will be seeing the total number of kilometers. For example, let it be 232 kilometers. Okay, for example, if I want to travel from Bangalore to Kerala, okay, so what will be the kilometer? So the kilometer may be, for example, 100. Friends, actually I don't know, simply I am just writing it. So we will be making an estimation of what is the kilometer to travel from Bangalore to Chennai or Bangalore to Kerala. Okay, so another thing is that we will be choosing the shortest path. Okay, for example, if I want to go from Bangalore to Kerala, okay, so I will be choosing the shortest path. I will not go from Bangalore to Chennai or from Chennai to Kerala, because there is a direct path present with total number of kilometers is very less. Only this I will be choosing, isn't it? So for that purpose we are using this weights. Okay, so the weight is nothing but the kilometer of traveling or a meter of traveling. So like this we can tell. So weight tells you the value of each and every edge. So if, for example, if 1 to 2, if I want to travel from the vertex 1 to 2 or from 2 to 1, they may fix the weight as 12. Or if I want to travel from 1 to 5, I may fix the weight as 10. So like this, for each and every edge we will be having some values. So based on this weights, we will be choosing which is having the shortest path, that is the shortest distance to reach between the source and destination. Suppose if this value is given both for the directed graph and for the undirected graph, it is called as a weighted graph. Suppose a weight is not given, they have given the graph very plainly, then it is called as an unweighted graph. Okay, so now we have discussed 4 types of graphs: directed, undirected, weighted and unweighted graph. Okay friends, so now we will go for the next graph type. Now we are going to discuss another 2 types of graphs. So it is a very important graph type. So they may ask in MCQs, or they may ask what is the difference between dense graph and sparse graph. Okay, so first you should know a graph consists of multiple number of vertices and edges for representing the relationship. So based on that we are going to discuss all the graphs. Okay friends, suppose if you have any doubt in definition of graph or meaning of graph, you can go to my previous videos, watch it and come over here. Okay friends, what is the meaning of dense in general? Can you please guess the answer? So the meaning of dense is nothing but it is going to go underneath, that is it is going to go deeper and deeper. So that is called dense, isn't it? So what is called sparse? So sparse is nothing but it is going to have some separation by having a few number of edges. Okay, so sparse is nothing but only few number of distances. Okay, few number of travel. So that is called as a sparse graph. So based on that we are having 2 types of graphs. So one is dense and another one is sparse graph. So what is dense graph? If you see, a dense graph is going to have huge number of edges. Okay, so dense graph is going to have edges that is being accumulated together in order to connect all the vertices. That is, at the maximum, how many number of edges we can build in a graph. So that much amount of edges are being held by using this dense graph. But in sparse graph, if you see, we are reducing the limit of edges for constructing the connectivity between the vertices. So by seeing these two diagrams, you will be able to have a clear idea. So the total number of vertices you see 1, 2, 3, 4 and 5. So here if you see 1, 2, 3, 4 and 5. But when you just visualize the total number of edges that is being present in all the vertices, so can you count or can you see? So the number of edges are more when compared to that of the number of edges in sparse graph. So if you see, dense graph consists of accumulation of maximum number of edges, but in sparse graph we are going to reduce the amount of edges in order to construct the graph. Okay, so that is called as your sparse graph. So now these are some of the differences. So as I told now, dense graph consists of number of, that is large number of edges, it is having few edges. Then next one, if you see, this is like a formula. So n number of vertices will hold at the maximum n square edges. Okay, so the total number of edges, if you just calculate and see for dense graph, it will be more or less close to that of this n square. But in sparse graph, if you see, number of edges is close to n. When you compare these two, this is having more number of edges when compared to that of this sparse graph. Okay friends, are you all clear? So that is the meaning of dense graph and sparse graph. So friends, so now we are going to discuss another types of graph techniques. So first is null graph, then trivial graph, connected graph, disconnected graph and complete graph. So among these graph, complete graph seems to be very important because it is holding a formula, so which you may be getting it in MCQs. Okay friends, so now we are going to discuss what is a null graph. So this is an example of a null graph. Okay, so can you find what is the meaning of a null graph now by seeing this diagram? So this is a graph, if you see. So this graph doesn't have any edges, isn't it? Normally if you see a graph will have a combination of edges and vertices. Okay, so there are also possibilities there with the graph without having edges. Suppose if a graph is present without having any type of edges, then those type of graph is called as a null graph. It is also a valid graph. Okay, so graph with having only vertices and no edges, then it is called as a null graph. So this graph is also a very valid one. Okay, so we cannot tell that it is not a graph. It is a graph with no edges. So what is the meaning that if there is no edges? So the meaning is we don't have any path to reach these vertices. So that is the meaning, isn't it? So that is a null graph. So it is a very important one. The next is a trivial graph. So what is called as a trivial graph? A graph is called as a trivial graph if it contains only one vertex. So the number of vertex will be only one. So only one vertex will be present in that graph. Okay, so no edges will be present and the number of vertex will not be more than one. It will hold only one vertex. So trivial graph is the smallest possible graph among the graph structures. So please make a note of it. So a trivial graph is called as, or it is considered as, the smallest possible graph among the different types of graph structures which we are discussing now. Okay, so it is a very important point, note down. So the next graph is connected graph. So if you understand this connected graph, you can be able to answer this disconnected graph. So what is a connected graph? So what is the meaning of connected? So meaning of connected is all the vertices have to be connected, isn't it? So that is the meaning. Then another thing is that a graph is called as a connected graph if there exists at least a single path to travel from source to destination without repeating the path. Okay, understand? So a graph is called as a connected graph if there exists a single path. Okay, if there exists a single path, at least a single path to start from the source and to reach the destination. So it is called as a connected graph. Okay, so there must be at least one path to start from the source and to reach the destination. There may be multiple paths also. Friends, are you all clear? There may be multiple paths also, and also there should be at least one single path. So that is called as a connected graph. So if you take this, for example, I want to start from A, I want to reach to D. Okay, I want to start from A and I want to reach to D. I must have to visit all the vertices at least once in between A to D. Okay, I want to start from A and I want to reach D, and the condition is I must have to visit all the vertices that are present in between A and D in order to reach my destination. Okay, so if I do like that, it is called as a connected graph. There may be multiple way of traveling between A and D in order to reach this destination, but the condition is at least one path should be there, at least. Okay, so now if I am going to start from A, I can go like this. Okay, and I can go like this. So can I go like this? See, we cannot able to reach. See, for example, I will just try. I can go move like this and I can go. So these two paths are not visited. So we cannot tell that this is a correct path. So once again we start with some other path. Okay. So if I start, I can move like this. Then I can move like this and I can go here, and from here I can reach. So now if you see, all the vertices are being visited once. So A is the starting location. I have visited B, I have visited C, and then I have visited E, F and D. So if there is at least a single path so that I can visit all the vertices and then I can reach my destination, it is called as connected graph. Okay. So can you all understand? The first path which I took from A to B and B to F was not a proper one. So I selected the next path in order to reach all the vertices and finally reach my destination. So now we will see what is a disconnected graph. So disconnected graph is just opposite to that of the connected graph. So in disconnected graph we cannot able to find even a single path to visit all the vertices in order to reach between the source and between the destination. Okay, so shall we check here? See, for example, again I want to start from A to D. Okay, we will see what all the vertices present. So from A I am reaching here. Okay, so then from B I am reaching here. Then from C I am reaching here. Okay, so if I go here, I cannot able to reach D, isn't it? Or for example, if I start from B and if I go to D, I cannot able to reach this here. So if I just traverse in any of the direction, I cannot able to satisfy the condition. So if it is like that, it is called as a disconnected graph. Okay friends, are you clear about this connected and disconnected graph? Right. So now we will go for a complete graph. So this is a very important question friends. So they may ask you in theory or in MCQs. So there are chances for you to get questions even in this. So this is having the maximum probability of doing some calculations, right? So now what is a complete graph? So complete graph is very easy. It is nothing but all the vertices are having edges. Okay, so all the pair of vertices will have the edges compulsorily. So if so, it is called as a complete graph. So all the pair of vertices is going to have the edge compulsorily. So for example, if you see from 1 to 2 there is an edge, from 2 to 4 there is an edge, from 1 to 4 there is an edge. So it is not like this. So if it is like this, 2 and 4 is not having the edge, direct edge. So if it is like this, it is not a complete graph. So if it is like this only, we can tell that it is a complete graph. So here if you see This is also one type of a graph having 3 vertices. So all the pair of vertices are having the edges. Okay, so this is also a complete graph. Can you understand? So a complete graph is a graph which is having edges for all the pair of vertices. Okay, so we can generally represent it as Kn. So Kn tells you the maximum number of edges that are present for n number of vertices. So n stands for number of vertices. Okay, so Kn tells you the maximum number of vertices, maximum number of edges a graph will hold with n number of vertices. Okay, for example, I want to find for K5, or for example, I want to find for K4 for this. Okay, so how many number of vertices are present? 1, 2, 3 and 4. So n is equal to 4. So I am going to use one formula to find this answer. So formula is n into n minus 1 divided by 2. So this is the formula used for finding the maximum number of edges for the given number of vertices. So n into n minus 1 divided by 2. So if you substitute, you will get n is 4, isn't it? 4 minus 1 divided by 2. So what will be the answer? 12 divided by 2. So you are going to get 6. So you will have 6 number of edges. Here the total number of vertices are 4. So you just count and see the number of edges. So it is 6, isn't it? So please by heart this formula. It is a very important formula. Okay friends. So Kn is equal to n into n minus 1 divided by 2. Okay, so up to now we have discussed null, trivial, connected, disconnected and complete graph. So up to now we have discussed few of the graph types. Okay friends, so in the future videos we are going to discuss yet the different types of graphs. Okay friends, so if you really like my way of teaching, I request you to subscribe my channel, so it will be a great motivation for me friends, right? Bye and thank you.